Alrighty, sort colors, medium. Given an array nums with n objects, colored red, red, white, and blue. Sort them in place so that objects of the same color are adjacent, and colors in the colors in order red, white, and blue. Sort them in place. We'll use the integers 0, 1, 2 to denote red, white, and blue. What is the point of calling these things red, white, and blue if they're just 0, 1, 2 in the array? Like, just call it like you have an array of 0, 1s, and 2s. And you're trying to sort them so that the zeros come before the ones. This is such a weird sugarcoating on this thing. Like literally there's nothing in here that says red, white, or blue. You must solve this problem without using the library's sort function. Sort them in place. What? Could you come up with one pass using only constant extra space? Okay. So they don't want you to create another integer. Like they don't want you to create a counter for the number red, white, and blue and just generate the array. Okay, fine. So let's think about this. If I have an array that is 2, 0, 2, 1, 1, 0. So let's say I have two pointers. Let's say I have a pointer at the front and a pointer at the back. Anything that is a pointer at the front keeps track of where the next zero should be placed, and then a pointer in the back keeps track of where the next two should be placed. Okay, but I want to do this in one pass, I guess. So even if I did like 3 passes where I counted, or 1 pass where I counted things, and then I moved things after that pass, that's not 1 pass. So you move your zeros to the front. So the 2 that you see here, you're going to swap it with the 0 in the back. And that 0 in the back goes to the front. So it becomes 0, 0, 2, 1, 1, 2. And then what? And because this is 0, this is fine. But what if it was a 1? So what if you actually started like that? So you see a 2 here, you know you need to swap it to the back. So now you have a 1. What do you do with that 1? I mean, I guess you swap it here, right? You have to swap it here. And now you go to the next element, which is the 0, and you swap it to the front. So it swaps the 0, 1. Okay, so let's go ahead and create a swap function. A, B are the indices, and say nums at A, nums. I guess it's a single line to do a swap in Python. So never mind. Okay. So what if you kept track of, so when you do the swap, so I think maybe I move the front pointer to the first non-zero element all the time. So while true, let's go ahead and have 2 pointers, a front pointer, front, actually I'll call this the 0 pointer, that is index 0. This is points to first non-zero index. And these pointers are going to be pointers to where to place stuff. So the 0 pointer points to the front stuff, and the 2 pointer points to the back. And while true, first up I need to move the 0 pointer if it's pointing to 0. While 0 pointer while nums at 0 pointer is equal to 0. Actually, well, 0 pointer is less than n. 0 pointer increments. And then while the 2 pointer is greater than or equal to 0, and nums at the 2 pointer is 2, 2 pointer goes forward. Okay. And now, maybe this should be a little for loop for index in range n. Let's say the value is whatever is at this index. And I think I just care about moving around 0s and 2s, and 1s can just do what 1s are just like floating. They get moved around automatically. So if the value is 0, then I'm going to swap the places for this value and where the 0 pointer is. The 0 pointer nums at 0 pointer is going to be set to 0. Actually, nums at this spot and nums at the 0 pointer should be now 0, and this spot should be now, so I move whatever was at the 0 pointer. Else, if the value is 2, the nums at the 2 pointer, nums at the spot swap. So it becomes 2, and again nums at the 2 pointer. I think this might work. No return. I wonder how this thing tells whether or not this is doing it in place. Out of range. 0 pointer should always be less than n. While 0 pointer is less than n. I guess. Okay, so what happens if the 0 pointer actually is n? Because I'm preventing it from going out of bounds here. But then it could still be n minus 1, and then it increments to n. So if the 0 pointer is n, then how did the 0 pointer become n? So let's go ahead and just print out when this thing breaks. Yeah, order of operations, probably declaration assignment for usage. Okay, so 0, 2. So it does the first loops, and it should be setting the 0 pointer to be over here and the 2 pointer to be here. So then it should be swapping them. So it should be swapping the Okay, yeah. So I was actually looking at this thing right here and swapping it with this thing over here, which I don't think I want actually. So if the value, if this index is actually before where the 0 pointers are, then this thing should just continue. This thing is, I don't want to do any swaps. So if the index is less than or equal to the 0 pointer, continue. Okay, stop going out of bounds. Okay, so 0, 2, and then 1, 0, and then when it's 1, 0, the 0 pointer should still be after the index, so it should continue. So I'm not sure why it doesn't, why it's printing this thing. This thing only prints out at the very end, and I should be hitting this continue. Index is less than or equal to the 0 pointer. 0 pointer should be, oh wait, am I looking at the wrong one? Oh, seemed, what happened in the last one actually? Okay, so actually it started here. So it should be swapping the 0 and the 2. And it should be ending up with 0, 0, 2. Okay, that's fine. And then the 0 pointer should be here. And the index should be here, so it shouldn't be swapping these. Yeah, so actually this, I mean, this is fine. Okay, so why didn't this thing print out on the first loop? So the 0 pointer is here. Oh, it should be just strictly less than. Okay, so 0, 0. So swapping these two, that's fine. And then it's skipping over this 0 because it's already correctly there. And now it's going to look at this element. Index 2. Index 2, the value there should be 1. But the value it thinks it sees is 2. Huh. Nums at the index 2. 0, 1, 2. Huh. 2, 2. Indentation in. Yeah, okay. Going on here. Okay, so yeah, that's 2, 2. Okay, yeah, right. The value there is 2. And then it's, since its value is 2, then it should be swapping with this thing. Yeah, it just needs a break. It needs to stop doing stuff when it hits the 2-pointer. Else if index is equal to the 2-pointer, and then break. Okay, so it worked on that case. Now, this case goes, 2 pointers here, the 0 pointers here. So, yeah, the 0 so the 2 should swap here and get 1, 0, 2. And then it's at the 0 and it's swapping. Okay, I think maybe when I do the swap with the 0 pointer needs to increment. That's right. And then I would do the swap with the 2-pointer. The 2-pointer needs to decrement. Because the movement, once you actually find a thing, then you need to move where the next thing is going to swap to. Although if that works, then why didn't the... I'm not sure why this one actually works, to be honest. Actually, is this necessary? Because then the next pass, this thing goes and this thing keeps on looping. I guess okay, so 0 swaps, or 2 swaps with the 1, and you get 1, 0, 2. And the index is now 1, the value is 0. The 0 pointer should swap with the 0 and 1. Why doesn't it swap? Is it breaking? Oh, because the index is equal to the 2-pointer. I see. Because the 2-pointer at that point is going to be at 1. And the index is going to be at 1. So maybe it just needs to be after. If the index is greater than the 2-pointer. It's not greater than. Doopy doopy doopy. Okay, yeah, I don't think I need this, to be honest. It's covered in the while loop. Yeah. And let's see how this compares. It's one pass. There's a lot of if statements, but what can you do? Oh baby, 1 2 0. So the 0 pointer's here, the 2 pointer's there. C's a 1. C's a 1. It doesn't need to do anything. C's a 2. It swaps the 2 with the, so it becomes 1 0 2. Interesting. And then it moves on to the next index, even though the 0 there is not correct. Interesting. So in theory, you need to repeat your check. Because the thing that you swap to the so you see a 1. See a 1. Like this could be a bunch of 1s, and then you see the 2 and you see a 0. No, it could be something where it's like a bunch of 1s, a bunch of 2s, and then a bunch of 0s. In which case, my algorithm is going to have the 2 pointer be here, the 0 pointer be here. It's not going to do anything with the 1s here. When it sees the 2 here, it's going to swap. It's going to make this into. It's going to make this into that. Then you need to still swap the 0 to the front. And then, but currently it's going to keep on moving the index. See, so this thing here, it's a 2, it swaps it to the back. So yeah, you get a bunch of ones, a bunch of zeros, a bunch of 2s. So how should you handle when you swap to the back? When you swap to the back, if it's a 0 that you're swapping to the front, then you need to actually do a second swap to make that 0 to be the front. Is that just an edge case, or is there a better handling of that? If the value is 2, if the value is 2 and the value at num's at 0, I mean, we could try to always do the shuffle. The value at 0 pointer is, the value at the 0 pointer is always going to be a 1? Is that the case? I mean, if the value is a 0 pointer, it can't be a 0 because then it would just increment it. The value at the 0 pointer, could it be 2? Value at the 0 pointer, can it be 2? Well, in theory, if the value at the 0 pointer was 2, then this would occur. Would it? There was always a 1 here, then I could maybe try to always do 2 swaps. So here, C's a 2. Just gonna swap this thing, and the value of the 0 pointer is going to be 1. Maybe you always do maybe you do something like this. Values to swap, and then immediately set your value to be whatever value that you swapped it with. Set this index, and then you do a second swap if necessary. All right. Ooh, wow, that was a pure guess. Okay. How do they know that you did this in place rather than, or one pass? I guess they don't know. Okay. I'm pretty sure this is, yeah, this is definitely one pass, right? It's index increases. You have a second pointer that always increases and another point that always decreases, but it's not like it's multiple passes, I don't feel like. anyways. Yeah. Okay. To non-zero index to swap zeros to, and points to index front index at that to swap zeros to. So you go through all your values, go through all your indices, get your value, and then there's a check to always move your pointers to as further as possible. Move pointers furthest possible past those zeros, twos. So your 0 pointer is going to move forward, passing zeros at that spot. Your 2 pointer is going to move downwards, backwards towards the front of the array, passing twos. If the current index is at a spot that's before the 0 pointer, then move past it. Basically, you need to, if your 0 pointer is past your current index, that means that you see a bunch of zeros. So you can ignore, like, it doesn't make sense to try to swap. Actually, I think maybe if your 0 pointer is, yeah. If this was like Java, I could maybe change the index variable. I would say index variable should equal 0 pointer at that point. So that you just skip the continue loops, because this is going to just keep going until index matches 0 pointer. Else, if your 0 pointer index currently, then block the zeros, no swaps needed, and then index at last block of twos. So algorithm is done. Array is sorted. So if your value that you have inside the stuff that's not sorted, it's like your value is 2, then you need to move it to the back to where the last spot for the 2 should go. So otherwise, not sorted, swap 2s to back, and swap 0s to the front. Okay, so summary. This is a 2-pointer technique. In general, you need to track both where 0s and 2s go. And note here that basically your 2-pointer technique is kind of weird, because then you have, it's almost like a for loop, a nested for loop, or multiple nested for loops, because kind of you want, in my mind, it often feels like you want to simultaneously move both the forward pointer and the back pointer simultaneously. Like you have one for loop that does both inside the loop. And the way to separate that is actually just have nested for loops and have an outer loop that is kind of independent of those movements. So this is actually kind of like 3 pointers, right? Because there's an index, which is another pointer, and then 2 other pointers. But although this outer loop could possibly be a while loop, so that, I don't know. 2-pointer technique, you track both zeros and 2. So when you see a when value not sorted, that is sorted, is detected, move that to either the front or back. Here, basically, we ignore ones as those as since moving all zeros and 2s to the correct spot will automatically leave ones in the middle, correct? And I'll just make one note here. Use independent, I don't know if that's the correct word, independent if statements. So not else if, for moving 2s first and 0s secondly. And this is the point here, like when you move the 2 to the back, it's possible that you swapped it with the 0, and then if it is a 0, then you need to make another swap for that 0 to move to the front. So swap value and be 0, need to reset the value in order to do the following statement. And this is swap it 0. Now there's other ways that I think I could have done this. I think this is the most elegant in my mind. I could have done like an if statement here if the value is 0, swap it to the front, or do a different version of the swap, like a 3 variable swap, 3 index 3 variable. But since they can be kind of separated in this way, it's probably simpler to see this. But this was not trivial to separate this from an if-else-if statement versus an if. Just have to reset the value and then do another if statement on the other value. Not trivial. Okay, this is going to be O(n), but this is also 1 pass. 3 values. I mean, it's kind of weird because pointers also kind of do a sort of mini pass. I don't know. I feel like you aren't really optimizing very much here, because 0 pointers actually go pretty far, and 2 pointers can go pretty far. So it's almost like you're doing 3 passes, where if you did 3 passes, then you could just do a freaking for loop of counts. And then, yeah, this is O(1), as no separate array is needed. You could also have done O(1) with 3 passes after counting.